Good evening, everyone. I hope I'm audible. Okay. So, welcome to the NPTEL live session for the seventh week on the course Integrated Waste Management for a Smart City. I am Abhishek Raj, a PMRF scholar in the Department of Civil Engineering, IIT Madras. So, coming to the outline for the seventh week. So, firstly, we will see an overview of the seventh week. What were the topics that were discussed in the seventh week? Followed by this, we'll discuss some questions from the practice assignment. Some of them will be polls where the students will have to answer the questions. And finally, we'll have some doubts with my comments. So coming to the overview for week 7. So firstly, we had the lecture 1. So this was about the environmental factors which affect biological degradation of waste. Then we had the air and water requirements, how to find them. So for this, there are chemical equations as well as some physical characteristics are also there which are used. Then we had lecture 2, so that was about the composting techniques that are employed. So what are the techniques? So we have windrow, we have mechanical, then also we have the static air piling system. Then we have the compost plant design. So what are the factors we need to consider? What should be the capacity? How much air we need to supply for degradation of the waste. Then we have lecture 3. So this was about anaerobic digestion. So what are the systems in this? So we have a batch and we have two-step or two-stage system. Then we have the design requirements for this, how to calculate the required amount of air supply to be given to the system. Then we had lecture 4. So this was about so if we see so the first 3 lectures, this was about biological treatment. And followed by this, the last 2 lectures of this week, they were concerned with thermal treatment. So we had the introduction to thermal treatment and then the reasoning behind why we should go with waste to energy. Coming to the last lecture, that was lecture 5. So this was about thermal conversion. So what are the benefits of thermal conversion? Also, what are the disadvantages? Why do we do it? Then what are the different processes that are used for thermal conversion? So moving on to the first question. So the first question is a poll. So which of the following is the correct sequence of anaerobic digestion of organic waste? So the first one is hydrolysis, acidogenesis, methanogenesis, and acetogenesis. Followed by this, we have hydrolysis, acidogenesis, and then the first option is jumbled. So it is acetogenesis followed by methanogenesis, acidogenesis, hydrolysis, methanogenesis, and acetogenesis. Then there we have hydrolysis, methanogenesis, aceto, and acidogenesis. So I will drop a poll in the Gmeet. The students can answer. This is question 1. Has 4 options: A, B, C, and D. I will give you 2 minutes for this. You can answer it in the chat also as well as. Let me check the responses. So we don't have any responses till now. We'll wait for a few more seconds. Then we will discuss the solution for this. We will end the poll. We will discuss the solution. So here we are concerned with the sequence of anaerobic digestion of organic waste. So organic waste will have different types of compounds, which will generally have a large molecular weight. So firstly, then they will go through hydrolysis. So here the large molecular weight compounds, they will be broken down into smaller compounds, organic weight, smaller molecular weight. Then we will have acidogenesis. So here the compounds with somewhat moderate or high molecular weight will be converted to acids of large molecular weight. So this will be heavy acid, and then we will have the acetogenesis. So here large molecular weight acids will be broken down into smaller acids of low molecular weight, such as acetic acids. And finally, on these acetic acids or other smaller molecular weight acids, so methanogenic bacteria will act, and they will convert this acetic acid to methane. So in the presence of these bacteria, it will get converted to methane. So firstly, we will have hydrolysis. So we can see that is in option A, option B, and option D. Then we will have acidogenesis. So there we have option A and B we have. So acidogenesis or acidogenesis. Then we have acetogenesis. So that is this one. Then finally we will have methaneogenesis. So we can see that option B is the correct answer, and A, C, and D are incorrect because they have the wrong order. So we'll discuss this using the slide also. So here option B is the correct answer. So students can refer to week 7, lecture 2. So firstly, we will have hydrolyzing bacteria that will break down the large molecular weight compounds.
డ్యూటీకి వచ్చారు ఎవడా నేను నా సీట్లో ఉన్నాను సార్.
So firstly, we will have the hydrolyzing bacteria. So they will convert the large molecular weight compounds to smaller molecular weight compounds. Then finally, then the second stage we'll have acidogeny bacteria. So smaller molecular weight compounds will get broken to large molecular weight acids. So this is stage 1, stage 2. Then stage 3, we will have these large molecular weight acids. So they will be broken down to acetic acid and other small molecular weight acids. Finally, in stage 4, we will have acetic acid, and that will get converted to methane. So we will have these 4 stages where different kinds of bacteria will act, and they will carry out the process of anaerobic digestion. Moving on to the second question. So which of the following is the food for methanogenic bacteria in the aerobic process? The given options are hydroxyl groups, methane, acetic acid, and protein and lipids. So we have been given the different types of foods, possible foods for the bacteria, and we need to find what is the correct answer for the methanogenic bacteria. So as we saw, so stage 1 we have hydrolysis, stage 2 we have acidogenesis, stage 3 we have acetogenesis, and finally in stage 4 we have methanogenesis. So what happens is, in this stage, the third stage, acetic acid is formed, and this gets converted to methane by methanogenic bacteria in the last stage. So what is the food for, or the reactant for methanogenic bacteria? So that will be acetic acids. So that is option C. So we will see this using the slide also. So option C, acetic acid is the correct answer. Students can refer to the second lecture of this week. So the end product of the acetogenesis step is acetic acid, which is a low molecular weight acid. And this acetic acid acts as the food source for the methane formers or the methanogenic bacteria. So in the last stage, that is the methanogenesis system. So moving on to question number 3. So this is a match the following type of question. So we have been given the composting technique and composting time. So we have windrow composting, aerated static pile, and in-vessel composting. Let me just check if someone is waiting in the GP. So yeah, we have 3 different kinds of composting techniques that are given here. So windrow, aerated static pile, and in-vessel, and corresponding times have been given. So they may be jumbled or they may be across. So we have to match them. So options have been given. So 1A, 2B, 3C, 1C, 2B, 3A, 1B, 2C, 3A, and finally 1A, 2C, and 3B. So A, B, C, D, 4 options are given. Actually, there should have been different letters here. That would make it more unambiguous. So let's take the capital A, B, C, D as the options. So here, firstly, we have, let's start. So we will have the most basic one, that is aerated static pile composting. So this takes a lot of time. So usually this takes around, so here we will have piles. So pile is nothing but there will be like the waste will be there, and there will be piles like long column-like structures through which air will be passed, which will help in composting. So this takes a lot of time, usually like close to 1 month, you can say it takes this process. So 1 month is around 30 days, or you can say like 4 weeks on an average. So 4 weeks, we can see that it will be lying somewhere in between this. So 2 will go with C. So let's mark it here. So 2 goes with C. Then we have windrow composting. So this is a somewhat improved method. So this takes a little less time. So around 15 days or 20 days it takes. So 2 to 3 weeks. So this is B. So 1 will go with B. Finally, we are left with 3. So that will usually go with whatever is left, but we'll still discuss that. So we have in-vessel composting. So since this is a mechanical method, it takes the least time, or you can say the process will be usually very rapid. So less than a week, we can finish this. 5 to 6 days will be quite enough. So 3 will go with A. So 3 will go with A. So we have 1 is B, 2 is C, and 3 is A. So B, C, and A. So we can see that is an option C. So the correct answer is option C. Moving on to the solution of this. So option C was the correct answer. So 1B, 2C, 3A. So students can refer to the second lecture of this week. So here we can see we have the aerated static pile. So material gets composted for around 3 to 5 weeks in this. We have the windrow composting. So here complete composting can be accomplished in 1 to 3 weeks, so relatively lesser compared to aerated static pipe. So here it is turned regularly, so up to 2 times per week we will do the turning using front end loader or some mixing apparatus. Finally, we will have the in-vessel systems or also the mechanical systems. So here the process will be rapid and usually it will take less than 1 week. Moving on to the next question, that is question number 4. So this is a poll. So calculate the oxygen requirement for the complete combustion of 100 grams of ethane. So given options are 3.73 grams, 37.3 grams, 373.3 grams, and finally we have 3733.3 grams. 4 options we have. I will drop a poll in the Gmeet. You can answer it accordingly. So this is question number 4. So I have lost the poll. I will give you maybe around 3 minutes for this. Since it is a numerical, it may take some time. So we have been given with ethane, 100 grams. We have to find the oxygen requirement for ethane. How much will be needed for its digestion? I will wait for 1 more minute and then we can discuss the answer. We don't have any response till now. The poll. close the phone now. We will discuss the answer for this question. So we have been given with ethane. So ethane is a compound of the alkane family. So its formula is C2H6. So for just for a reference, I will tell you. So the formula for any alkane will be CnH2n plus 2. So here ethane means it means like 2. So N is 2. So hydrogen will be 6. So this is the way to find the equation for a formula for alkane. So ethane is C2H6. So now we need some oxygen for its degradation. So since it is an organic compound, what will it form? So it will form CO2 plus H2O. So these will be the two main compounds. This equation is not balanced as of now. So firstly, we will need to balance this equation. So as we have seen in the class also, so if we have a compound, let's say CaHbOC and Nd. So this will be the general structure of a organic compound. So it can have this, sometimes it can have sulfur also. So this will react with 4A plus B minus 2C minus 2C divided by 4 O2 ACO2 plus B by 2 H2. Let's check it. So this is the general structure of the equation. So this is balanced. So depending upon the values that we have here, A, B, C, D, so we can find the required number of moles for the other compounds. So here we can see we have let's see, we have C2H6. So A is 2, B is 6, and C and D are 0. So how much oxygen do we need? We need 4A plus B minus 2C by 4. So that will be 4A plus B minus 2C over 4. So this will be 4 into 2 plus 6, C is 0 divided by 4. So this will be 14 over 4. So 3.5 moles of oxygen we require for 1 mole of ethane, that is C2H6. So here we have been given 100 grams. So let's shift it here. So 100 gram ethane means we have 100 divided by what is the molecular weight of ethane? So it will be 2 carbon. So it will be 12 into 2 for 2 carbon, and hydrogen will have weight 1. So 1 into 6. So it will be 30 grams. So 100 by 30, this many moles of ethane we have been given. So for 1 mole of ethane, we require 3.5 moles of oxygen. So 100 by 30 means it will be 3.33 moles. So for 3.33 moles of ethane, we will need 3.33 into 3.3 moles of oxygen. So this, let's do this calculation. I think it will be greater than 10. So this is around 11.655 moles oxygen. So this is the amount of oxygen we need. Let's change the color. So this is the amount of oxygen we require. So weight of O2 will be molecular weight of O2 into moles of O2. So this would become molecular weight of O2 is nothing but 32 grams, and moles we have 11.655 moles. So this will be basically gram per mole. So we measure in that way. So 32 into 11.655. So this is coming out to be around 372.96 grams. So we can round it off to around 373 grams. So this is the oxygen requirement for 100 grams of ethane. So answer will be option C. So I hope this was clear. We'll just wait for a few seconds. If anyone has a doubt, rest we can move on. Just wait for maybe a few seconds. If anyone has any doubt. Yeah, so lignin content, yeah, there is one question on that. Come to it. So maybe we will move on. Anyone does not have any doubts. So
ওষুধের খাবার আবার দুর্গাপুর বলে দেখা যায় দুর্গাপুরে
So students can refer to the third lecture of this week. The answer was option C, 373 grams. So here is we have the balanced equation. So you can see here. So for 2 moles of ethane, we require 7 moles of oxygen. So for 1 mole, we will need 3.5 moles of oxygen. So 2 moles require 7 moles. So 60 grams, we'll need 224 grams. So we can accordingly find using unitary method. Moving on to the next question, question number 5. So what is the ideal pH range for anaerobic digestion of waste? So we have been given the options A 6 to 7, B 7.5 to 9.5, C 6.5 to 7.5, and D 7.5 to 8.5. So for anaerobic digestion of waste, we don't want the pH to be on the extremes. We want it to be very optimal. So we can have two possibilities here. So it can be slightly alkaline or it can be slightly acidic. So slightly acidic will be around 6.5 to 7, like little below the neutral point, that is 7. Slightly alkaline is around 7 to 7.5 or sometimes little higher. So if we combine these two ranges, so 1 and 2 will have around 6.5 to 7.5. So this is the range that we should try to maintain. We should not go very basic or very acidic. So or we should try to maintain it around 7. We can go little below, little above, because we need to provide for some tolerance. Maintaining exact pH is not very easy. So always there will be some tolerance. So option C, 6.5 to 7.5 is the ideal pH range. We'll see this using the slide. So students can refer to the second lecture of this week. So to maintain an anaerobic treatment system, the non-methanogenic bacteria and the methanogenic bacteria must remain in a state of dynamic equilibrium. So how will we achieve this dynamic equilibrium? So there will be certain criteria for it. So first will be pH. So that should be 6.5 to 7.5. And when the pH drops, like it becomes acidic, so in that case we'll need alkalinity. So how do we provide it? So we'll provide in this values, so around 1000 to 5000 milligrams per liter, and alkalinity units will be in ppm of calcium carbonate, that is the SI unit for alkalinity. So we do this when the pH starts going below 6.2, because we don't want the pH to go very acidic. So in that case, we will provide alkalinity in this range, depending upon how much we want to achieve, or how much we want to adjust the pH. Moving on to question number 6. So calculate the biological volatile solid content for the given waste composition of agricultural waste. So we have moisture content of 26%, volatile solids 80%, and lignin content of 5%. So the given options are 0.69, 0.66, 0.78, and 0.80. So we know the BVS, that is the biological volatile solids. So there is an empirical equation for it. So that will be 0.83 minus, it will be around 0.02. Let's remove the bracket from here. So 0.028 into, there will be certain lignin content. So here the lignin content we should put directly in percentage, and it will give us the BBS in the requisite units. So substituting the values, so we have 0.28 minus 0.028 into lignin content is given as 5%. So let's put the values. So this will be let's check the calculation. Atoms should be 0.83. You can use it with this 0.06. So this will be around 0.83 minus, this will be around, I think, 0.14. So this will turn out to be 0.69. So it will be an option A is the correct answer for the biological volatile solids. So option A is the correct answer, 0.69. Students can refer to the third lecture of this week. So BVS is given using this empirical equation. So 0.83 minus 0.028 into lignin content. So we put the value of lignin content, we got the value of 0.69. Moving on to question number 7. So the thermal processing of waste in the absence of oxygen is called. So the given options are incineration, plasma arc, pyrolysis, and gasification. So when we do thermal treatment, it can be either like aerobic or it can be anaerobic, means either in the presence of oxygen or it can be in the absence of oxygen. So here we are concerned with the absence of oxygen. So incineration is aerobic. Plasma arc is also aerobic in some sense because we need to heat up to a very high temperature, so we need oxygen for that. Gasification also will have some aerobic nature, but if we talk about pyrolysis, this will be anaerobic in its entirety. So option C is the correct answer. So students can refer to the 5th lecture of this week. So the answer was pyrolysis. So here we have the following thermal processes. So presence of oxygen will do certain things. So incineration, cogeneration, energy from waste, co-incineration. And here gasification will do partial combustion. So it will not be entirely aerobic or entirely anaerobic, but pyrolysis, if we are concerned with, so that will be in the absence of oxygen. Moving on to the next question, question number 8. So the organic fraction of biodegradable components that get destroyed or reacted during biological treatment is termed as inorganic solids, fixed carbon, biodegradable volatile solids, and residual volatile solids. So we have the municipal solid waste, we'll have two fractions. So organic, inorganic. So inorganic, there can be biological volatile solids, or it can be residual volatile solids. In organic, we can have inorganic compounds, and within organic itself, we can have other compounds which will not be volatile essentially. So we'll have one group of volatile, another group of non-volatile. So this can contain compounds such as fixed carbon or residual ash. So here we are concerned with the biodegradable component. So that gets reacted. So we don't want anything to remain. So it should be essentially volatile. So volatile and biodegradable. So biological or biodegradable volatile solids is the correct answer. So that is option C. So fixed carbon is not volatile. So it is like involatile because it will not get reacted. Inorganic, it can't be the answer because we are concerned with organic. So A, B are not the answers. Residual volatile solids will still remain. They won't get reacted. So D also is not correct. So answer is option C. So biodegradable volatile solids, option C. Students can refer to the first lecture of this week. So here we can see the pie chart for composition of waste. So the blue for light sky blue portion is biological volatile solids. So this is the organic fraction which will get destroyed during the treatment. We'll have some water, that is moisture. We'll have some inorganic waste and then residual volatile solids which will still remain after treatment. Moving on to the next question, question number 9. So what are the advantages of thermal processing of waste? Loss of energy, energy recovery, volume reduction, and both B and C. So when we do thermal processing, so what happens is there will be a certain volume reduction because when we are essentially doing combustion, so we have a solid fuel, so it will get converted to different things. So there will be some energy, mass energy conversion will happen. There will be some ash, there may be some smoke. So one unit is getting divided into smaller units. So there will be a certain volume reduction. So if we are burning, so basically ash is the solid portion that remains. So there will be a certain change in volume observed in the negative direction. So option C is correct. And then we can also do some energy recovery because there will be some heat energy or even light energy obtained. So option B is also correct. So there won't be loss of energy. Essentially, we are trying to pull out energy. So it is recovery of energy. So since both B and C are correct, that we have in option D also. So option D will be the correct answer. So option D was correct, both B and C. Students can refer to the 5th lecture of this week. So here we have the slide on thermal conversion. So thermal processing of waste is used for volume reduction, that is the first, and for energy recovery, that is second. So it has been an important component of integrated waste management. So standalone systems are not good. So many places in abroad we have started using, or we are using thermal conversion plants. So moving on to question number 10, which is a poll. So which of the following statements are true regarding anaerobic digestion? So batch systems produce low methane than the two-stage system. Batch systems are ideal for developed countries. A two-stage system of anaerobic digestion is better than the batch system, and batch systems are producing more methane than the two-stage system. So I will drop a poll in the Gmeet. You can answer it. So this is question number 10. So I'll just give a hint. Here, 2 of the options are correct. So please answer. You can answer. Even if you answer one, it's fine. Because it's a poll, only one. We'll accept one choice. I'll give you maybe 2 minutes for this, then we'll discuss the answer. We'll give around 1 more minute, then we will discuss. Okay. If someone has responded A in the chat, just check the poll. So no responses in the poll. We have any more responses in the poll? No response. And then the chat we have two responses, A and B. Discuss the answer now. So here we are concerned with the types of processes that are used in anaerobic digestion. So we will have first will be batch systems, and second we will have two-stage system. So batch system will be essentially, so we will have the anaerobic reactor. So the waste will go in accordingly with the other things that are needed, such as air. There can be some sludge that is needed to increase the efficiency of the process. So depending upon that, the waste will go in, and then we'll take out the final product that can be methane or the processed sludge. So this process has certain demerits, like here we need to keep different factors in control, such as oxygen, alkalinity, acidity, pH. Different things need to be kept under control in this reactor because it is a batch system. Everything is happening within this one system, one reactor. So here, due to the low efficiency of this process, it needs to be stopped in between, like to check for many things, many parameters, what are the values. If oxygen is less, we need to supply. There are many things happening together. So here, methane produced is lower. So batch systems produce low methane than the two-stage system. So A is correct. So the batch systems are producing more methane than two-stage systems. So D is not correct. So then we have batch systems are ideal for developed countries. So this is wrong. So it is generally good for developing countries where infrastructure and budget is less. So there it is better. So B is also incorrect. So we are left with C. So let's check it. So a two-stage system of anaerobic digestion is better than the batch system. So here what we'll have one for the acidogenesis stage and another will be the for the methanogenic bacteria. So here we will break down the solid waste into acids, and there we transform the acids to methane. So we can see there are two stages in the process. So stage 1, stage 2. So since we have two stages, the control here is better. We don't need to control for many parameters because only one sub process is happening in one reactor and then it is going to the other reactor. So control becomes better. So here the methane that is produced is higher in volume. So it is better for than the compared to the batch system. So C is correct. So A and C are correct. So option A, batch systems produce low methane than the two-stage system, and option C, a two-stage system is better than the batch system. So A and C are correct. Students can refer to the second lecture of this week. So the batch system will have a large footprint, but it will have a low methane production. So it is ideal for developing countries. Whereas here we provide home for the acidogens, and then for stage 2 we provide for the methanogens. So this will have high cost, but kind of improves methane production. So two-stage system is better. So moving on to the next question, question 11. So what are the different inorganic compounds present in solid waste? Metals, cellulose, proteins and fats, and glass. So as we saw, so solid waste can be of basically we can classify depending upon the nature. So it can be organic, inorganic. So within inorganic, we will have different things. So it can have metals, it can have glass. So you can see cellulose is organic. So cellulose is nothing but fibrous material will contain cellulose such as cloth fibers and all that. Proteins and fats, this will come from the food waste generally. So these two are organic. So this is organic, this is organic. So B and C are not correct, whereas glass and metals are inorganic. So this is inorganic. So A is correct. Glass is also inorganic. So D is correct. So A and D are the correct answers. So metals and glass can refer to the first lecture of week 7. Moving on to the last question for today's session. So this is a poll. So what are the different aerobic combustion techniques of thermal processing of solid waste? So pyrolysis, incineration, plasma arc, and cogeneration. So I will drop a poll in the Gmeet. Maybe you can answer it. You can also answer it in the chat. Last question, question 12. A, B, C, D. Four options we have. Yeah, so I've dropped the poll. You can answer it in the poll as well as the chat. Okay, so someone has answered A. I'll give you around maybe 2 minutes and then we'll discuss the answer. We have two responses now, A and D in the chat. Just check the poll. No responses in the poll till now. So I'll just give a hint. So two of the options are correct here. So answer accordingly. Only just one. I think someone has added one more option. Few more seconds, then we will discuss the answer. Okay. I said A and B and D. We close the poll. So here we are talking about normal treatment. So it can be two types, maybe three types also we can say. So one will be aerobic, anaerobic, and there can be some hybrid techniques, which will be the combination of aerobic and anaerobic. So in aerobic, we will have techniques such as incineration, cogeneration. Anaerobic, we will have pyrolysis. Hybrid, we can have like gasification. So here we can see we are concerned with the combustion techniques or the aerobic techniques. So that has incineration, cogeneration. So here we can see, so B is there for incineration and D is there for cogeneration. So pyrolysis is not aerobic, it is anaerobic. So this needs to be noted. So correct answers are option B and D. So option B, incineration, and option D, cogeneration is correct. You can refer to the last lecture of this week, lecture 5, for this question. So combustion is basically thermal destruction in the presence of oxygen. So we have incineration, cogeneration, waste to energy, co-incineration. So it will be a combination of the above three techniques. Pyrolysis will be in the absence of oxygen, and gasification will be partial combustion. So that's why it's like a hybrid procedure. Plasma will heat up the gas to a ionized state. So this completely destroys all the bonds. This will be somewhat expensive process. So this was the last lecture for, sorry, this was the last question for today. So if anyone has any doubts, you can ask. Please feel free to. Thank you all for attending the session. If you have any doubts, you can ask. Else you can log out. We'll wait for 2 minutes and then we'll close the session. Don't think anyone has any doubts. So I will close the session now. Thank you for attending the session.